Hello. Well, I think we're going to talk a little bit about subtracting mixed numbers with regrouping. Now, this is a pretty short lesson, so it shouldn't take too long. And it's not something that you're unfamiliar with. It's just a good thing to go over it. There's a little bit of vocabulary for this particular lesson. The word is regrouping, and you use regrouping when you subtract all the time in a normal subtraction, but this is a little tiny bit different when you're doing fractions, mixed numbers and fractions. The actual vocabulary definition for regrouping is exchanging a value for an equal value or an equal amount. For instance, if you would change 1 10 into 10 ones. If you're making change at like the grocery store or something like that, you might do that. Say, could you give me 10 ones for a 10? That would be exchanging, that would be regrouping. Or 1 whole for 4 fourths. 4 fourths really means 1, you know that. And 1 and 4 fourths are exactly the same. But you know, we use those interchangeably, like when we're multiplying to try to find equivalent fractions. We multiply by 4 fourths, which is really just 1. I call that my well-chosen 1. Okay? Here's a problem that we might like to try doing some subtraction of fractions with. Okay, this particular number, or this particular problem, I guess, is significant. If you have 4½ pies on a shelf and you give away 1 2/3 pie, okay, how many pies will you have left? Okay, so we would probably want to subtract. Let's write it out. 4 1/2 minus 1 1/3. Now, you do need to notice right away that the denominators are different. This denominator is 2, this denominator is 3. We cannot subtract anything until we have the same denominators. So, we need to see if we can remedy that situation. And I know we can, because I know you've done it before. We need to find a common denominator so that we can subtract. There's 2 ways to look at this, okay? One of the ways to look at it is we could, on the left here, we could turn both numbers into improper fractions and then find common denominators, and then you could subtract, which is kind of a long drawn out process, but it works if you're in a pickle and can't figure out what else to do. Okay, the other side over here is to set them up vertically and use regrouping to help us subtract. This is a quicker way to do it, and once you get the hang of it, you'll want to use it all the time. Okay, so here we go. We have 4 1/2 and we want to subtract 1 2/3. Now, if you look at the denominators, you can probably see just by looking at them that a good common denominator is probably 6, and that would really make a lot of sense to me too. To get this common denominator, we have to do something to the denominators of these 2 fractions. 3 only becomes 6 if you multiply it by 2, and what you do to the bottom you must do to the top. 2 only gets to be 6 by multiplying it by 3. And so what we do to the bottom, we must do to the top. So let's rewrite. We have a denominator of 6, so we don't have to rewrite the 6, but we do need to write the numerators. So again, 1 times 3 is 3, 2 times 2 is 4, and now we have a problem, because 3 minus 4 doesn't compute with us when it comes to fractions. We don't want negative fractions in this particular situation. So since we can, I think we'll go over here to this 4, and we're going to borrow from it. We're going to borrow 1 whole, and it's going to become a 3, and we're going to bring 6 6 over to here. Okay, so instead of having 3 6, we are going to make this 3 plus 6 6, because we already had 3. We're going to add 6 more on, 6 and 3. So this is now 9. because we added up here. We took the 3 that was there, we borrowed 6, 6 from here, took it up here, so now we have 3 plus 6. 6 and 3 is 9. 9 minus 4 is 5, 6, and that comes from here. And then we still have to deal with these numbers over here, the whole numbers, and 3 minus 1 is 2. So your answer is 2 and 5 6. Okay? Let's do a couple more practice ones just to make sure you understand the concept, okay? So we have 3 and 5 eighths and 1 and 7 eighths. Now, there's no story that goes along with this one. We're just going to see if we can work through it. Kind of easy because guess what? The denominators are already the same. So that helps us a little bit, okay? So we have 3 and 5 eighths and we have 1 and 7 eighths. So don't need to change the denominators, so we'll just take 5 minus 7. And again, we have the same problem. We have 5 minus 7, which gives us a negative 2, and we don't want negative 2, so we're going to borrow or regroup. So this 3 becomes a 2, and because we're dealing in eighths, we're going to have 8 brought over here, plus the 5 that's already there, and 5 and 8 are 13. So we now have 13 minus 7 over 8. And 13 minus 7 is, let's think on that just a minute. Oh yeah, 6. 6 over 8. 2 minus 1 is 1. We probably should reduce this by dividing by 2 and dividing this by 2. So we end up with 1 and 3/4 as an answer. Okay, let's do another one. Okay, what happens when you have a whole number? How many thirds do we have here? 7 and none. 0 thirds. Okay, so we're definitely going to have to regroup to be able to do this subtraction problem. So right now we have 7 and 0 thirds minus 1 and 2 thirds. So we end up with 0 minus 2. Well, we can't do that. We get negative. So we're going to go over here to the 7. We're going to make it a 6. We're going to bring 3 thirds over because we're dealing in thirds. So this becomes 3 plus 0. Okay, and so instead of being a 0 here, we have a 3. 3 minus 2 is 1 over 3. Okay, and 6 minus 1 is 5. Answer, 5 and 1/3. So even if we have a whole number here, we can deal with this, and be sure that this goes in your notes so that you know what to do when you have a whole number. Lastly, we can use this method when we are working with percents that have fractional elements. Believe it or not, and this one's a lot like the last one we were doing, so it's kind of cool. 100 minus 16 and 2/3. These are both percents, okay? But I didn't put the percents over here because they just get in the way. When we get done, we'll have to leave it as a percent. So we have 100 and 0 thirds, right? Because it's a whole number. And we want to be able to take 0 minus 2, which we know right now doesn't work. So we cross this out. We're gonna borrow 1. So now this is 99, right? And we brought 3 thirds over, so this becomes 3 plus 0. And now we have 3 minus 2, which is 1 over 3, right? 1/3. And then we have to take 99, which is what's left on the top, minus the 16. 6 from 9 is 3. 1 from 9 is 8. And you add your percent sign, and you are done. Hopefully this was helpful. It wasn't a very long lesson, but I hope it helped. Thanks a lot. Talk to you later.